Natural versus artificial intelligence. We use our brain and we produce through our intelligence some products. For example, we produce the programming language C or any other language. The programming language is a set of codes. We can use these codes to create something else. For example, the programming language C Python, which is a level higher than the programming language C. The code of this, and with this new programming language, we set up a large and comprehensive library which contains algorithms. These algorithms are already pre-programmed. Then, using the codes of C Python or Python, which is the next version of C Python, using these codes, we can develop or create, if you want, AI tools like ChatGPT, Copilot, and many other AI tools. In other terms, we are the creator, or the brain is the creator of what? Of a creature which is the C language. Now, when we use the C language to create C Python, the C language becomes a creator. So it was a creature with respect to the brain, to the human brain, but now it is also a creator for C Python. C Python is a creature with respect to C, which is the creator or the designer, but C Python is a creator for AI tools which come next. So we have a chain of creators and creatures. It is possible to use C directly to produce AI tools. The price or the cost is that we should develop kilometers of codes. In other terms, we miss some opportunities. We miss the power of C Python because C Python is associated to a large comprehensive library or libraries which include powerful pre-programmed algorithms. It is even possible that we use directly our brain to develop AI tools, maybe using assembly languages or machine languages. It will be very, very complicated, but it is feasible. So indeed, we create intermediate tools like C and C Python to have some agents which will facilitate the design of the end product like ChatGPT.
Natural versus artificial intelligence. Today, we observe the coexistence of two distinct forms of intelligence, natural and artificial. Natural intelligence has existed for millennia. It emerged instinctively, and it is embedded in all living organisms, most notably in humans. It is through the human brain that reasoning, creativity, and adaptability have developed to extraordinary levels. By contrast, artificial intelligence is a recent development made possible only through the capabilities of natural intelligence itself. In other words, AI is not self-originating, it is a creation, a product of the human mind. This progression can be illustrated through the evolution of programming languages. The C programming language, one of the earliest powerful languages, was designed by human developers to express logic computationally. From C, more expressive languages such as Python were developed, and today, Python plays a central role in the development of many AI systems, including advanced tools like ChatGPT. In this layered architecture, we can trace a chain of creation. The human brain created C, C enabled the development of Python, Python in turn facilitates the development of AI tools. Each element in this chain, brain, C, Python, AI, may serve both as a creature and a creator, depending on the level of abstraction. It is important to note that while it is theoretically possible to create Python directly in assembly code or to develop AI directly in C, such efforts would be extremely complex and inefficient. These dependencies reflect not just historical progress, but also functional necessity in managing complexity. Furthermore, while the brain could, in principle, produce the same outputs as modern AI systems, such as code, analysis, and documentation, the time and cognitive effort required would be dramatically higher. Tasks that may take an AI tool minutes could demand months, years, or even centuries of human effort. This contrast emphasizes the efficiency and scalability of artificial intelligence, but it also reminds us that AI remains entirely dependent on natural intelligence for its design, training, and ethical grounding. Understanding this foundational relationship is essential as we continue to develop and deploy AI in increasingly critical domains.
If we are able to make profit from pre-programmed libraries, why don't we do the same with the brain itself? In reality, the brain has some libraries also, some algorithms which are instinctually available, and some of them are evolving. Means the human brain is learning all the time. The brain has at its disposal mental computing, some logics, reasoning. It has a memory, and the brain can develop the memory. It has some search mechanisms. It also has sentiments and feeling. It also has a library of moral rules, a code of ethics. More than that, the brain operates with a modular system. Tasks are divided into modules like we do with algorithms. We have to inspire from this, because if you would like to develop responsible AI, we have to explore the moral library in the brain itself. As I said, the brain works in a modular way. The brain is controlling all organs in our body, including the heart. But the heart itself is a module. Not only the brain includes thousands and billions of neurons, the heart also includes around 40,000 neurons. It does mean that some tasks are done locally at the level of the heart. So we have a modular system like the one here. So the heart is connected to some intelligent components, and all the system is collaborating with the brain. We see very deep similarity between the brain and the machine, the same stakes in reality. We can then conclude that understanding the brain and the way it works is very helpful to program the machine. Understanding this lineage is crucial.
The foundations and stakes of intelligence. To understand where artificial intelligence is heading, we must begin by examining a fundamental question. Where does intelligence derive its power? This exploration is essential if we are to predict the future of intelligence, be it natural or artificial. But before looking forward, we must understand the foundations. One of the first questions often raised is, who is more intelligent, humans or machines? This question, while common, is misplaced. Intelligence is not an isolated, absolute quality. Rather, it is expressed through the products it generates. So instead of comparing human intelligence to artificial intelligence in isolation, we should compare the outputs, the tangible results produced by each. These outputs, whether human or machine generated, are influenced by a number of conditions, external and internal factors that shape performance. In our framework, we enumerate 15 such conditions, which include specialization, the domain-specific knowledge or expertise available, time availability, the duration allotted for thinking or computation, speed of processing, particularly relevant in computational systems, volume and access to data, including the ability to remember or, conversely, to forget, number of intelligent agents involved, enabling collaborative or distributed intelligence, evolution and adaptability, or what we call evolving algorithms. Let's consider some practical examples. It would not be reasonable to compare the work of two intelligent actors, whether human or machine, if they specialize in different domains. The context and required knowledge may be fundamentally different. Likewise, comparing one actor who is given only 1 hour with another afforded 3 weeks would produce misleading conclusions. Time is not a neutral factor. It directly impacts the complexity and quality of the outcome. And consider memory. One actor may forget crucial information as humans naturally do, while the other, such as digital AI systems, may retain perfect memory. stored in permanent and searchable databases. In such a case, the second actor has a decisive advantage in accessing and mining relevant data at speed, an advantage that profoundly alters the nature and value of its outputs. This leads to a key insight. We might assess intelligence not in isolation, but through the lens of these 15 performance conditions. Only then can we build a fair, meaningful comparison between different intelligent agents and better understand how AI may evolve, adapt, and contribute in the years ahead.